as a reminder, let's just make sure it's actually recording. Yep. As a reminder of this, so we're going to have public class, hello in this case. I don't care what you named your class as long as you had a class name. And then it's public, static, void, main, string array. You can name your variable for args whatever you want. You can call this elephant if you want, but it's got to be a string array. And then system.out.println, hello world. Make sense? All right, how many people got it? Good. Now you remember me warning you that I'd be giving you a quiz on this, right? The good news is you will have future opportunities to fail this quiz. So that means if you didn't get it this time, go and memorize it again so you don't not get it again. And for those of you who got it, don't forget it. Lots of free quiz grades. So almost guaranteed, whenever I feel like we're due for a quiz, if I don't have a good quiz question, I'll use this as a backup. So this will be asked as a quiz again, so it would behoove you to memorize it. I can almost guarantee you there will be a quiz. One of the questions on the midterm will be this question. Should be free points. All right? And again, this isn't just an exercise in memorization. You will start every single one of your Java programs with this structure. So committing this to memory is an important thing to do. All right? I'm typically not necessarily a big advocate of memorizing a whole bunch of stuff since we will have resources available to us. But there are certain structures that we use all the time that make sense for us to memorize, right? Structure of a program, the syntax for an if statement, the syntax for defining variables, what our primitive type variables are. That'd be another good quiz question at some point. List all the primitive types. What are the primitive types? And char. Yep, so byte, short, int, long, char. Usually you think through the integer ones first. The chars are one unsigned integer, 0 to 65,535. I won't ask you those numbers. Okay? That's trivia type knowledge, not things I expect you to remember. Then float double. So floats are kind of like ints. Doubles are kind of like longs. Hold bigger values. And then our Boolean. Make sense? All right, so I'll never ask you to give me the numeric range. It would be a fair question for me to ask you what is the range of values for a 32-bit number, a 32-bit signed number. That would be plus or minus 2 to the 31st, because 1 bit's for the sign. That would be more of a question about, do you understand that the difference between signed and unsigned numbers? But there's a low likelihood of a question like that. It's still a risk. They'll never ask you to come up with the negative 32,768 to positive 32,767 thing. That's human calculator stuff. Or teaching this for a very long time and remembering the number of over the years. Okay, homework for today was the FizzBuzz dealio, right? All right, so good news is for a couple of you who are also in the Apple Watch programming class learning Swift, you got to do the same assignment twice in 2 different languages, right? And you hopefully noticed that it was pretty similar in both languages, right? So let's go ahead and write it in here. I think, what it was, 100 to 100,000? Is that the range? 100 to 1,000, okay? So you were supposed to start off, so we're kind of drilling, writing loops and asking questions and dealing with variables, and we're kind of drilling those programming basics that we've learned, and we're going to continue doing that today. But let's start off with that. So we're going to loop through all the numbers between 100 and 1,000. So we're going to start off with a loop that does that. So it's a counting type loop, so it'll probably be a for loop. So let's start I off at 100. We'll keep going as long as I is, you could say less than 1,000 or less than or equal to 1,000, or you could say less than 1,001. I don't really care if you included 1,000 or not. I don't remember if I specified in the homework, but frivolous, unless he messed up and then he only gets a 35%. Doesn't even know his name. All right, and then we're going to say I is equal to I plus 1. We haven't done the plus, plus, minus, minus stuff yet, have we? Okay, I'll talk about that today. For those of you who maybe have done some Google searches, you've probably seen some stuff that looks like this. Okay, I'm going to explain it today. I purposely don't use it yet until I explain it. It's a kind of an important concept to understand the ramifications of using it. So we'll talk about it.
If I would have done that, would you?
I'm not going to take off points. Yeah, it does the same thing, but it's important to understand the differences. Yeah. I play one on TV, but in real life, I'm not a full-blown jerk. Unless I'm grading his stuff. Oh, I get such enjoyment from that. All right, so anyways, now we have a structure. We have a loop that's just going to go through all the numbers, in this case, between 100 and 1,000 inclusive. So it'll also hit 1,000. Each time through it'll go, 999. Is 999 less than or equal to 1,000? Yes, it is. Do something. 999 becomes 1,000. Is 1,000 less than or equal to 1,000? Yes, it is. Do something again. 1,000 becomes 1,001. Is 1,001 less than or equal to 1,000? No. Now we're done. Okay? So all this structure does is takes I on a voyage between the number 100 and the number 1,000. What we do with that value during that voyage is now up to us from a logic perspective. All right? So this loop as it is right now has nothing to do with the fizz-buzz problem. We're going to talk about strings some today. We'll use loops to spin through every character in a string, all sorts of stuff like that. So loops are just taking a number typically. For loops, we're typically doing counting problems, so just taking a number on a voyage from a starting value to an ending value and stepping by some number. In this case, we're stepping by 1, but we can certainly step by 4 if that made us happy. Okay? Now, each time through, we want to ask a series of questions. So depending on the current value of I, we either want to just print out I, print out the word fizz, print out the word buzz, or print out the, is it a phrase fizz buzz? Wordy, double word fizz buzz, thingy-majiggy. Perfect. So depending on the answer to our questions, so we want to ask him some questions. If the number that we're currently looking at, and the number each time through is I. That's the one we're interested in. Okay, remember this loop takes I on a voyage, and then we're going to do something with I each time. Or at least use I to solve the problem we're trying to solve. So if I is evenly divisible by both 3 and 5, it has to be evenly divisible by both of those things, we're going to print out fizz-buzz, right? So we're going to start off by formulating that question with that Boolean expression. So if I, when divided by 3, has a remainder of 0, I mod 3 equal to 0. And remember, it's the double equal sign, not the single equal sign. What's the difference?
A single equal sign like assigns a value to a variable. Double equal sign kind of actually compares the values.
Okay, so single equal signs are assignment operator. Assigns a value to whatever's to the variable on the left-hand side. And the double equal sign is our equivalence Boolean operator, which always boils down to true or false, right? Okay? And we're building a Boolean expression here. What's a Boolean expression? Go ahead.
True, false. It has to be true.
Yeah, any expression that boils down to a single value of true, false. All right, so we need 2 things to both be true in order for this question to be true. So that should start telling us we probably need to use an and. We need 2 things to both be true. So if I, when divided by 3, has a remainder of 0, this is our modulus operator that returns for us the remainder of integer division. Okay, so this is third grade math that we've all forgotten. Then we have the ampersand, double ampersand. So this is the AND operator. Trivia knowledge, what's the single ampersand? We talked about it last time. Yeah, the bitwise Boolean operator. We will rarely use it. I'll never quiz you on it. But just reinforcing some knowledge, it'll be back there. But more for the reason is this is going to be kind of a common mistake that you forget to do it twice. And then you'll start getting funky results because you forgot to do the double ampersand for AND, and instead you just did the single ampersand, which does that whole bitwise at the binary level. 1 and 1 is 1, 0 and 1 is 0, 1 and 0 is 0, 0 and 0 is 0, so on and so forth. Okay, so you're going to get funky results, not what you were expecting. So rule of thumb, check that if you start getting funky results. So if I mod 3 has a remainder of 0 and I mod 5 has a remainder of 0, if both of those statements are true. And again, this whole thing is a Boolean expression. A Boolean expression is any expression that boils down to a single value of true or false. We have a Boolean expression right here. We have a Boolean expression right here. Each of these guys will boil down to true or false, and then we're going to apply the AND logical Boolean operator to those two Boolean values to produce for us a single Boolean value. Make sense? Therefore, this entire complexy looking thing is in fact a Boolean expression. So if both of these things are true, we're going to do a print, system.out.println, fizzbuzz, one word like that. All right, so it would be a word, not a phrase. All right, so that's what we do in the case where it's evenly divisible by both. If that's false, so we're only going to do this, if this thing boils down to true. If it's false, we're going to keep cooking. Go here. All right, so we're going to have an else. Now, I'm going to actually write this in the, I'm going to write this in the way that I verbally teach, and I'm going to write it in the way that I actually teach because they actually conflict with each other. And that'll make sense here in a second. So I'm going to have an else in here. Most of you probably said else if right here, okay? And we'll come back to that because it actually conflicts with my teaching, although I usually write it that way. So else, we're going to ask some more questions. If I mod 3 has a remainder of 0, that means we already know it's not evenly divisible by both. Let's see if it's evenly divisible by one of them. Okay, so if it's evenly divisible by 3, system.out.println fizz. Else. We're going to ask another question. Well, now we know it's not evenly divisible by both. It's not evenly divisible by 3. Let's see if it's evenly divisible by 5. Else. So if we're in this else, that means it wasn't evenly divisible by both. It wasn't evenly divisible by 3. It wasn't evenly divisible by 5. Therefore, we're just going to print out the number. Okay? Now, first of all, writing it this way is good practice for curly braces. Okay? But writing it this way also is visually intimidating. Now let me explain why. So first of all, this is the correct logic. Okay, so we can go ahead and run through this, and we get a whole bunch of outputs. There's all our numbers, fizzes and buzzes and fizz buzzes, all those dudes. Okay, so let me now explain the contradiction and then we'll fix this. Okay. Oh, Not going there, we're going here. That's not this class. This is. What class is this? 250. I have to convert myself back to Java. I spent the last hour teaching Swift, and then this morning I was helping a student with Scheme. So we're putting semicolons back at the end of our lines now. That's the Swift to Java move. All right, so let's talk about the if statement thing again. I probably mentioned it up here when we talked about conditionals. Did I really? Yeah, here. We talked about the syntax for conditionals. Okay, I'm going to go a little deeper with this because it's actually kind of an important concept, specifically with if statements. The official syntax, the formal syntax for if statements in Java is not what I've written here. The formal syntax is that. If, open parenthesis, Boolean expression, close parenthesis, one statement. Okay, and this is something we talk about quite a bit in the 470 programming languages class. Now, the words, well, except I need to spell this right? I was testing you guys failed. 35%, of course. So, in any case, we have one statement. Now, just like some Boolean expressions can look more complex than others, but they ultimately are still Boolean expressions, statements come in a lot of different forms. Okay? The statement we're used to seeing after an if statement most commonly is the block statement. That is, this guy is a collection of 0 or more statements. That's the guy we commonly see after an if statement, which allows us to have multiple things in there. But we could certainly just say if A is less than 5, system.out.println A, something like that. That's perfectly legal. I would never write it all in one line like that, but that's just in this deal here. Let's just do this so I don't teach you bad habits. So if Boolean expression statement, that's the formal syntax. Okay? The syntax I teach is if Boolean expression, open curly brace, I usually say something like body there, but this would be really saying 0 or more statements. But really, you'd always have at least one statement in there, right? Otherwise, why are you writing a loop? If you're not going to repeat something, you're just kind of doing crazy stuff. All right? That's the syntax I teach. Now, technically, let's kind of show an example here. So if I say if, just assume there's a variable named A here for us to work with. A is less than 5, system.out.println A. That will work just fine. That's equivalent to this in terms of output. Okay? These two things are not equivalent. One thing we want to make sure we do is we want to make sure we're always indenting. Okay? So our code looks structured. But in this particular case, our indentation is deceiving us. This code right here actually acts like that. The second statement here, the second system.out, is not part of this conditional because the generic syntax for conditional says one statement. And since I did not use the block statement, I get one line. Okay, if I want to have two print lines happening with an if statement, I need to surround it by curly braces. So both of those things are linked to the if statement. All right, so as I have it written here, this guy can be deceiving if we indent. Now visually we think both of these guys are linked to the if, when actually only the first statement is. The second guy, they're both linked to the if. Not because they're indented, but because they're inside of a single statement. This whole thing here is a single statement called the block statement that happens to hold two additional statements. Make sense? What I teach is to always, always, always use the opening and closing curly braces. Okay, even though I've shown it's optional in certain circumstances, it's never wrong to use the opening and closing curly braces. It's never ever wrong. And I think it also makes your code look more structured to have the opening and closing curly braces. And I think I probably mentioned you'll see some syntaxes that look like that. Did we talk about this at all in here? Okay, so nothing wrong with it, but that really came from trying to save lines in a book. So I would strongly encourage you, if you don't already have a habit of writing it like this, if you already have a habit of writing like this and you're not inclined to switch, it's not that big of a deal. But I would encourage you, if you're trying to form habits now, to write it like that. Okay? So here comes my contradiction. I just said always, 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 always use the opening and closing curly braces because it's never wrong. So, what did I do in my code here? I always, 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 always use the opening and closing curly braces. So, here's my if statement, here's the opening curly brace, here's the closing curly brace. And we optionally can have an else with an if statement. Okay, so here's my else, opening curly brace, closing curly brace. Here's my if, opening curly brace, closing curly brace. Here's my else, opening curly brace, closing curly brace. Starts getting a little bit crazy, right? Realistically, I would have moved this if as part of that else. Let me just do this. Just cut the rest of it out of here so we can just retype it. So I would have said else if this. Else if five. Finally, an else. All right, so clearly that looks cleaner, right? Clearly that looks cleaner. But technically, I do not have opening and closing curly braces associated with this else. I have a single statement, and that statement is this if statement. That's my one statement, my one and done statement. And that if statement actually comes with a built-in else. Okay, so the statement associated with this else is actually this if-else structure. The statement associated with this else is actually this if structure. The statement associated with this if is actually, well, it's actually this guy. And then its else is this entire structure down here. Okay? So I've actually broken my own rule by choosing to omit the opening curly braces to produce cleaner code. So it's consistent with the idea of my code's more readable, but it's inconsistent with that rule of thumb that you should always use the opening and closing curly braces because it's never wrong. In this case, it's going to be a lot cleaner to take advantage of the fact that a if or an else is in and of itself a single statement. Kind of make sense? All right, so I guess in your mind, treat this as an exception to the rule. The other way wasn't wrong. We'll get the exact same output, but this looks a whole lot cleaner. But I would strongly encourage you to, in other circumstances, use the curly braces. All right, questions about this? So this was the homework. This is all I asked you to do. All right. Any questions on that? We all get it done? Work okay? All right. So now let's talk about some new stuff. So we'll start off. I don't know what I'm going to do with this. Maybe. There, now it fits. So plus plus and minus minus operators. So we'll talk about those quickly. All right, so let's just use a fictitious variable named I. So we have an integer named I that's equal to some value. Actually, let's just define it. Int I is equal to 5. I plus plus is the equivalent to saying I is equal to I plus 1 in terms of the ultimate final value. We are assigning back into I the result of the current value of I plus 1. Okay? Now, the plus plus and the minus minus operator can actually come before or after the variable. So I'm also going to say this. Plus plus I is the same as I equals I plus 1. I minus minus is the same as I is equal to I minus 1. And minus minus I is the same as I is equal to I minus 1. In terms of the final result, all of these guys are identical. Okay? Now, if we just left it at that, we're almost guaranteed to run into some problems in the future. Okay? And here's why. Let's go into our code here. Everybody write this down that wants it written down. All right, so I'm going to go ahead and create an integer I is equal to 5. All right, and we're going to say I is equal to I plus 1. Let's just do a couple of print statements here. So when we first create I, we'll go ahead and print it out. System.out.println I. Then we're going to say I is equal to I plus 1. And we'll print I out again. So what should print on this first line? 5. What should print on the second line? 6. Okay, and then not rocket science, right? So there's our 5 and our 6. Okay. So now we'll say I plus plus. What should print out? Same exact thing. Okay. On the slide we said they're equivalent in terms of the final result. What about plus plus I? Same thing. They're equivalent in terms of the final result. All right. Now, this is where we start getting into trouble with these guys. Often programmers will take the plus plus and the minus minus operators and use them to try to save themselves a line of code. So they might do something like that. So in this case, this first line is going to print out a 5. The second line we expect to print out a 6. Right? What's it going to print out? Print out a 5. But if we print it out on the next line, it'll be the 6. Having the plus plus come after the I, the plus plus come after the I says boil down to the current value of I in terms of this expression, and then add 1 to it. So what are we printing here? We're printing the current value of I, but before we get to the next line, we will then add 1 to I and restore the result back in I. We're doing it afterwards because the plus plus comes after the I, as opposed to this, plus plus I. Plus plus I, since the plus plus comes before the I, we're actually going to do the adjustment first, then boil down to the new value. So this will be a 5 and a 6. 5 and a 6. And notice the final result's still the same. Make sense? Okay. Now, just like the opening closing curly brace suggestion, good rule of thumb is, well, never inline the plus plus and the minus minuses in a situation like this. Nobody's impressed if you do that. You might as well just say I plus plus on its own line, then print out I and be done with it. This is perfectly clear as to what the result will be, right? Now, when you look at code online, you will certainly see people doing the I plus plus and the plus plus I in there, and it's not bad programming per se. But it is problematic programming, it's error-prone programming until you completely understand the ramifications of that. It's also potentially bad for whoever's going to have to go and read and maintain your code later in case they've forgotten this little fact about how the plus plus and the minus minus operators work. They might glance at your code and think it does one thing when it actually does something else because they didn't understand about the plus plus or the minus minus. Make sense? All right, so my recommendation is always put them on separate lines. You'll never run into trouble. So that's the story there. Something else we can't do is you can't say I plus 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 and expect it to be the same thing as I is equal to I plus 2. Not the same thing. Why? Because I plus plus will boil down to the value of I, which in this case is 5. And saying 5 plus plus doesn't mean anything. Okay? Because 5 plus plus is not the same thing as saying 5 plus 1. 5 plus plus also inherently assigns the result back into a variable. Therefore, you need a variable for it to work on. All right, so that's why we can't do the I plus 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 plus. You need to say I is equal to I plus 2. Okay, we do have a shorthand for that. They're called compound operators, where we can say I plus equals 2. I plus equals 2 is the same thing as saying I is equal to I plus 2. So we have a plus equals, a times equals, a minus equals, a divide equals, a mod equals. We have all those guys. All right, so all this does, this little compound operator, is it saves us from having to write the variable a second time. You never, ever, ever have to use this syntax if you don't like it. All right, but it does allow you to save a little bit of typing if you need to change your value by more than 1. The plus plus and the minus minuses are for making a change, a permanent change of 1. All right, questions on that? Okay. Now the plus plus stuff, I could see that making a decent quiz at some point where I give you some couple of variables and some statements and ask you to tell me what it prints out. That would be a good test of that knowledge. Hint, hint. Okay. So that's that. Let's just throw a slide in here real quick for our compound operators. So we have plus equals, we have minus equals, we have times equals, we have divide equals, we have mod equals. Those are our compound operators. Okay, next thing we want to look at is functions. Okay, and then we're going to come back and start talking about strings. So we want to be able to write reusable chunks of code. Things that we can write once and do multiple times and see kind of where they fit in our programs. All right, so we're going to start off. We've already talked about variables in Java, so that's our memory. We've already talked about conditionals in Java, that's our asking questions. We've already talked about loops in Java, that's our repetition. Okay, so now we have those tools in our toolbox, which I say all programming languages will have. Now we're going to start moving into some of the specialty things. Realistically, most programming languages have some way of mimicking functions. Okay, but it's not necessarily a rule to become a programming language. That's why I leave it off of our list of how do human beings solve problems and how do programs mimic it. Okay, so in object-oriented languages like Java, we call these guys methods. All right, so we're going to say methods equal functions equal procedures. We'll talk about that here in a second. Equal subroutines equal etc. So through the history of programming languages, these same animals have been called by different names. Okay, they're all the same. They're all a named chunk of code that we write one time and we can call as many times as we want, giving it some inputs for it to accomplish a task. Okay, now in some older programming languages, they differentiated functions from procedures, where functions were things that returned a value, procedures were things that did not return a value. Modern languages that have methods, for example, or like Swift has gone back to calling them functions instead of methods, whatever. But now they're all encapsulated into a single animal where you can choose whether or not you're going to return something or not. So your return type can be void, which means I'm the old school procedure, the dude who doesn't return anything. Okay? Or I can make my return type something else, which means I'm the old school function, where I return something. So let's look at the syntax of methods in Java. So we have return type, followed by method name, followed by opening parenthesis, followed by params, that's our parameter list, or maybe we say inputs, followed by opening curly brace, followed by closing curly brace. We can say 0 or more statements. Okay, just like that. So that's our generic syntax for methods. So let's go write a couple. For right now, we are going to, I think I mentioned it before, we're not going to talk about the static keyword for a couple of weeks yet. So we're not going to talk about it right now. For right now, every method just starts with the word static. Roll with that. Okay? So we'll say static. And now we're going to have our return type. So this guy's going to be void. I'm not going to return anything from this method. And we're going to call this method print hello. And this method is going to take no parameters as input. And inside here, all we're going to do is say system.out.println hello. Okay? That's all this method does. It requires no inputs, and it just prints hello to the screen and returns nothing. Now, an important concept here is there is a very big difference between displaying something to the screen and returning a value from a method. This method does not return anything. It does not spit an answer back to whoever called it. All it does is display something to the screen. Okay? We'll see the alternative to this in a second, but just kind of keep that knowledge in your head. So what will the output of this program be? Nothing. Why?
Because you aren't calling the method.
Not calling the method. This is a reusable chunk of code that we write once and call as many times as we want. How many times have we called it? Exactly 0 times. All programs begin and end with main. here's our main method up here, and right now our main method literally does nothing. So I can write 5,000 different functions down here, 5,000 different methods down here, and this program would still have an output of nothing because I don't actually call them from main. Okay? Now, I'm going to get us into a habit of doing something here because it's going to help us explain the static keyword later. But right now I'm going to give a halvesy definition to static. We're not going to go any deeper into it than that for right now. But for static, I'm going to say owned by the class. Okay? Static members are owned by the class. That could be static variables, that could be static methods. Okay, so this guy is owned by the class. With that in mind, and that's a very primitive definition. We're going to go a lot deeper into static later on. With that in mind, since this method is owned by the class because it has static out front, to call this method, we use the name of the class to call it. Okay? So I'm going to say hello dot, and you notice it shows up in there. Eclipse gives you command completion. Print hello. All right? Those of you who have written stuff in here before know that print hello will also work. That's perfectly legal. I encourage you not to write it that way, at least for a while. Okay? This has to do with, because we are in a static, what's called a static context right here, because I'm inside of a static method, I don't actually have to say who owns the method I'm calling, if it's also a static method, if it's from the same context. Okay? But that gets a little bit deep for beginning programmers. So punchline here is, if you have a static method, call it with the name of the class in which the method was defined. This class name is hello. Method was defined inside of the class named hello, so we call print hello using the name of the class. The other perk is if we use the name of the class and do a dot, it gives us the list of all the static members of that guy, so we can just call it. So I'm going to call print hello, so we don't have to worry about spelling errors. Make sense? So multiple perks. So in this case, what would the output of my program be? 2 hellos. All programs begin and end with main, so I start right here at the beginning of my code. I go into my code. Code says, oh, print hello. Call print hello. Come back here to my code. Call print hello. Come down here. Go through this. Hit the closing curly brace. Come back here to my code. Kick it down a line. Hit the closing curly brace. Now we're done. All programs begin and end with main. Yep.
What about the
Public, private, protected, all that stuff we're going to talk about later when we get into objects. For right now, you can just leave them all off. Yeah, main has to be public. What he's talking about is this guy right here. Main has to be public. That's why I say structure it like this, because this function automatically gets called by the Java virtual machine at runtime. So it has to be public in order for the Java virtual machine to be able to access it. Okay, but right now, we're not dealing with the difference between public, private, and protected, but we will. We will. So for right now, whenever I ask you to write a method, start it with static, and don't worry about anything else for public, private. We're doing everything within a single file right now. It'll just work and be okay with that for right now. I'll fill in all the gaps later. All right, so this makes sense. So we wrote a single program or single method and called it twice. But this method returns nothing and takes no parameters. So let's go ahead and write another method. So again, we'll start with static, and we're going to return an integer. This guy's going to return something different than nothing. So whenever we're going to not return anything, we say void. If we're going to return something, we say what kind of value that something will be. So this guy's going to return an int. And we're going to call this method addNums. And we're going to say addNums takes 2 parameters. Maybe it's an int a and an int b. So we're going to take in 2 numbers and we're going to add them together. Fair enough? So we're going to return a plus b. Notice that this method returns a value. This method displays a value. Very different. Okay, this one just spits it to the screen and that's it. This guy spits it back. So we're going to go ahead and call this method. So this method is a static method called addNums. How do we call it? How do we call this method? Hello dots. There's our addNums. And what two numbers would we like to add? Maybe 3 and 7? Like this. Okay, what's the output of our program going to be? Somebody who has an answer before. I'm attempting to trick you. Hello, hello, and hello? Why didn't you get tricked? Yeah, I'm returning it. Yeah, so this guy right here will boil down to the number 10. 7 plus, so I'm going to pass in 3, I'm going to pass in 7. 3 will come in for A. 7 will come in for B. We'll add 3 and 7, get a 10. We'll return that 10, so it'll come firing out of here. So this line right here will boil down to 10. And what am I doing with that value? Nothing. I'm not printing it. I'm not throwing it in a variable. I'm just letting it zip by. Okay, so the output of this program will be just hello, hello. Even though indeed this function did get called. It was called, and we chose not to do anything with the value that came back. It's kind of like going to the cafeteria and using the toaster, putting the bread in there and just walking away. Never actually, that happens all the time. There's always free toast in there. All right, so if I want to do something with this, I can print it directly. I can say system.out.println. All right, so now I'll get my 10, right? But if I need to get that 10 again, I have to call the function again. So I printed the value that came out of this function, but I did not preserve the value that came out of that function. If I need to use it more than just this once, I should probably put it in a variable. We talked about that last time. Rule of thumb for when to use variables. Whenever you need to use a value more than once. All right, so with that in mind, I'll probably say int answer is equal to this guy. And then we'll print out the value of answer. So we'll get the same output as we just had a second ago. Still got the 10, but now we've preserved the result of calling addNums inside of a variable named answer. And why did I make answer of type integer? Yeah, because this guy returns an int. So since this guy ultimately boils down to an int, I better catch it in something built for holding an int. So this is going to cause some issues. If I create a variable named answer and I happen to make it a char, and I'm trying to catch something that's of type int, Java's not a happy camper. It's giving us a type mismatch, cannot convert from int to char. Okay, well, I can throw this in here and say char. That's what's called typecasting. And this is going to be okay until it's not okay. When would it be? We've already talked about chars versus ints, right? What's the difference between an int and a char? Under the hood. Ints hold 32-bit signed numbers, right? What do chars hold? 16-bit unsigned. 16-bit unsigned numbers. So the biggest number that will fit in a char is what? The 65,000 some odd number. So if I try to throw the number 100,000 into a char, it's not going to fit. Will 100,000 fit in an int? Yeah, easily. That's the plus or minus 2 billion number. Okay, so instead of doing a 3 and 7, if I do 300,000 and 7, I'm going to get my answer, and my answer is not going to be able to hold that value. because 300,007 is greater than 65,535. So I've never actually run this like this. I wonder what happens. I wonder if Java upconverts this. Yeah, doesn't know how to deal with it. Char is not big enough. Realistically, this should probably throw an error, a runtime error. So I'm not necessarily a huge fan of just the question mark because, you know, Java didn't necessarily have any, they don't know at this point when we're going through, when the compiler is going through this line by line, it doesn't necessarily know what addnums does. We've happened to name our function addnums. In Java, they're called methods. Swift, they're called functions. That's why I've been flip-flopping them, but I've covered myself by saying that they're all the same. Okay? So I'll never question you as to what's the official Java term for it, I promise. So Java, just because we've named it addnums, that's really for human eyes. We can look at that and assume, okay, this guy probably adds some numbers. Okay, but Java doesn't know that. So Java doesn't necessarily realize that we're passing in this and we're passing in this, and it's going to spit out a number that's this plus this, which is too big to fit in one of these. This right here is something called typecasting. Okay, and typecasting, I know what you're about to say. You're about to say it's printing out the Unicode value, right? Yeah. So this is doing something called typecasting, where it's kind of trusting us. It's saying that, okay, you must know better than us. You've said you want to turn this into a char, so we're going to go ahead and do that for you, and we'll hope for the best. Okay, so this char is capturing the result of this value. In this case, the result can only be held by a 32-bit value. It's bigger than 16 bits that a char can hold. Okay, now clearly it's being captured inside the char. The reason it's a question mark down here, as he was going to point out, is the terminal here in Eclipse is incapable of showing the entire Unicode character set. It's capable of showing just the ASCII character set, the 255 characters, 0 to 255. Okay, so anything beyond that, it just prints question marks by default. Okay, which tells me that under the hood, the current version of Java must be representing chars as larger values. Otherwise, this should error out. So this must be at least a 32-bit value, or at least have some sort of test on it. Somewhat unimportant for us. What we're really drilling home right now is that if you're going to capture the result of a function, capture it inside of a variable built for holding the type that function returns. Okay? So if I want the answer from addnums, I should probably put it inside of an int. Like that. And now I can use it. It's preserved, so I can print it out there. I can then print it out, I can multiply it by 2 and print it out again. That kind of stuff. So I have access to that variable, that answer from that function multiple times. Make sense? Okay, so that's the rule of thumb when we use variables, when we need to use the answer again, and also the difference between a function that returns a value and a function that does something. It doesn't have to print, but we could just, for instance, go through here and say for int I is equal to 0, I is less than 100,000, I plus plus, and maybe have a int count is equal to 0, and say count plus plus in here or something like that. We're doing a whole lot of mathy stuff and literally doing nothing with the values. Nothing illegal by it, kind of a waste of time. Print hello no longer accurately represents what we're doing in here, but perfectly legal code nonetheless. Okay, again, we're not returning a value. We don't see the keyword return anywhere in there. And all we're doing is we're counting. And notice that Eclipse gives us a little warning. It underlines it in yellow, saying this variable is never used. The value of the local variable count is not used, just in case you were interested. That you're kind of wasting your time here. Okay, so the output of this program will no longer be the hellos. Now we just have our two math problems. We still called print hello twice. And what did print hello do? Well, it just counted all the numbers between 0 and 100,000. It did nothing with that value. Waste of time, but still legal. So we might say, oh, well, maybe we just want to return the count there at the end then. Well, now Java is going to scream at us. Why? Well, I've advertised this guy's not returning a value. Yet I'm trying to return a value. So I either need to advertise I'm going to return a value or not return a value, one of the two. Make sense? Okay, so that's our return type stuff. Let's flip this back to when it was the hello world thing, or hello. Okay, so that's kind of our introduction to methods in Java. A couple things to point out here. If we were programming in an older language, so for example, a language like C or even C++, early C++ compilers. So now we talk about the evolution of our compiler technology. Early compilers were single pass compilers, which means it went through your code. Now, first of all, remind me, what's the job of a compiler? What's a compiler do? Go ahead.
To translate your program into bytecode.
Yeah, fair enough. So what we say, there's two kinds of programming languages, compiled and interpreted. Compiled languages use a compiler prior to runtime to translate our high-level code, like Java, into a low-level language like bytecode. Okay, or assembly code for C and C++, that kind of stuff. Okay, so the compiler does this before runtime, and it has to go through and turn our high-level code into the equivalent magic tricks for the CPU. Okay, early compilers did this in a single pass, which would have wreaked havoc. Oh, I got a text from my wife. I thought I had gone into like the Hey Siri mode, where it was like capturing my entire thing as a big voice dictation. It's actually a very funny way to end a text message. She said she was reporting the weird smell of the diarrhea. Did not make that up. It's our cat. She was telling me she was emailing the vet. But out of context, hilarious. In context, still sort of funny. Yeah, my cat has had an infection for about 2 months. It's cleared up now, but now from all the antibiotics, there's some aftermath issues involving diarrhea. So, but she's doing much better, except for the diarrhea. What was it talking about? Oh yeah, diarrhea. Okay, so in any case, we were talking about single pass compilers. That would have wreaked havoc on our code here, because our functions are all defined down here. Yet, as we're going through our code line by line, we're hitting this line. If we pretend like we're the compiler, we're hitting this line, then we're hitting this line, then we're hitting this line. Right here, the compiler is going to try to execute, is going to try to interpret the syntax. The problem is, it's never heard of anything called print hello, because print hello has not been made available to it yet. It hasn't hit that code. So it's going to read this as a compiler. Make sense? Doesn't know about it. So what are our options? Well, we can move our functions up to the top, so it hits those first. And Java's fine with that. The order isn't important. So we can move all these things up here. No harm, no foul. So remember, we kind of advertised our class here as kind of like a garbage bag. That classes hold a collection of stuff. We talked about that it holds fields and constructors and methods, so we at least mentioned that at this point. We haven't done the fields and constructors yet, but so as long as it's between these opening and closing curly braces and it's one of the animals that a class knows how to hold, we're safe. Okay, so no harm, no foul. I would say typically when you're writing console-based Java programs, though, main comes first in the program. Since all programs begin and end with main, from a human being perspective, we kind of like seeing main right there at the top so we can see what our program is going to do. As soon as we deviate away from this and we start doing more object-oriented programming, we're going to see that our class that has main in it is significantly smaller than all the other files. Okay, because really main is just going to be almost like the director or the maestro of our application, where it's going to say call this function, create this class that does this, and then those other guys are going to call other things. So main is going to look very simple. In most cases, it just kind of gets the ball rolling. All right. So naming conventions would typically dictate this, or program structure would dictate that usually main comes first. All right. So in a single pass compiler, this is going to be a problem. So what did we do? In older languages, we did something called prototyping. So the fix prototyping. This was creating almost a shadow of what our function looks like without the actual implementation. Okay, so a shadow of what the function looks like without the actual implementation. Just enough information for the compiler to be able to check something like this line for its accuracy of how it's being called. Java does not care what print hello does here. Java cares about how print hello should legally be called. And if it knows that print hello looks like this, all it needs to know is that part of it. That it returns nothing, that it's called print hello, and that it takes no parameters. That's the prototype portion of that. So in older languages that use single pass compilers, what you would have is you'd have a lot of your functions written here at the very bottom, but you'd have them prototyped at the top. Make sense? All right, so that way the one pass compiler could function. Now, beyond this, we're going to say the better fix. One issue with that, having a single pass compiler going through your entire program one line at a time, like we just showed, is still going to have issues with the chicken or the egg problem. If you have one function that's going to reference another function, whichever one came first doesn't know about the other one. Okay, stuff like that. So what they did is they actually moved the function definitions, those prototypes, out of the current file. So they split your program into two files. And this is where header files were born. That is files, usually .h files in most languages. Okay, so header files contain a collection of function prototypes. That's it. Bunch of function prototypes, no implementation inside of a header file. Good news for us, Java doesn't have these anymore. Or Java never had these actually, but this is more where we got to where we are today. And then what we would do is inside of our main program, we would import that header file at the top. So it was a way for us to divide those two apart. So we had one place with all our prototypes and then another place for all our implementations. Separate those two. Because in really large applications, you might have 500 lines of prototypes at the top. As opposed to now, you'd have maybe you can divide those prototypes into a whole bunch of different subcategories, put them each in separate header files, and then import 20 header files at the top or 8 header files at the top, something like that. Okay, so it was an organizational benefit. So that was the better fix. Well, then we came up with two-pass compilers. So 2-pass compilers made an initial pass to read in all the function signatures, among other things, and then a second pass to do the conversion to low level. All right, so it did the job of that prototyping for us. Make sense? Now, and this is really a rule of thumb for us anyways, is as our compilers have evolved, we've had 2-pass compilers for a long time, but even those compilers keep improving. What does it mean for a compiler to improve? It means it's producing higher quality, more efficient, low-level code given the same high-level code. So the short version of that is it makes bad programs look like better programs at the low-level programming language level, which then further supports what I argue, that write easy-to-read, accurate code first. Worry about optimizing it second, because there's going to be a lot of situations where the compiler itself will do code optimization for you. It won't change your logic, okay? But it'll do things like convert an integer to a byte or to a short in terms of memory footprint, if it can determine that you're not holding a value greater than 10 or something like that in it, okay? It will magically do some of that stuff for you, so that for us as programmers, we can just say, well, we're going to use an int all the time unless it's not big enough. So we're doing it because we just don't care. We have plenty of memory, but the compilers are saying, well, we care a little, so we're going to fix it for you. Make sense? Okay, so that's our evolution of compilers. Not an issue for us today because we have 2-pass compilers. We don't need to worry about the prototyping stuff. So from our perspective as Java developers, and with really any of our modern languages, this stuff is not a problem, where we can use functions inside of a method before they're actually defined because of how the compiler actually works. Make sense? All right, you do have another homework assignment up. Your homework assignment for next class is actually to take what you did for this class, the FizzBuzz, and move it into a function. Move it into a method where that method takes in a minimum and maximum value. So instead of starting at 100 and going to 1,000, you'll start at min and go to max and print out the results. Okay? So you should be able to then call your FizzBuzz function multiple times, passing it 1 and 1,000 one time, 10 and 40 the other time, so on and so forth. Sound good? All right, and that's already up on Blackboard. I'll see everybody on Thursday. I put up on Slack already. There is the first day of the student, faculty, staff Bible study today. Starts at noon to 1. Comes with free lunch. Me and a bunch of students usually head down now. Let's go into the cafeteria, sign in. You can bypass the line. You get a free lunch out of it, and go down to Bible study in the terrace room. All right?
I did not do that quiz.
Okay.